Defining simulation settings, part 2. 53. Shift to the third tab, Sampling, and make sure the settings are exactly displayed as on the following window. 54. Set the sampling type to Latin hypercube. This setting specifies the type of sampling used during an at-risk simulation. Sampling types differ in how they draw samples from a distribution. Latin hypercube sampling, the recommended type, more accurately recreates the probability distribution specified by distribution functions. In other words, it takes fewer iterations to achieve the same accuracy when compared to a Monte Carlo sampling. 55. Leave the generator as its predefined text of Mersenne twister. The generator is an algorithm for generating a sequence of numbers whose properties approximate the properties of sequences of random numbers. This sequence is not truly random because it is completely determined by an initial value called the seed. At-risk comes with 8 different algorithms. Its choice belongs to higher numerical mathematical analysis. Our recommendation here is to never change this parameter and just leave it as it is on at-risk's recommendation. 56. In order to guarantee reproducibility, set the seed as a fixed one on any arbitrarily chosen value. In this case, we will use 1985. The seed number itself does not have any special meaning. As long as you choose a positive integer number smaller than 32 million, at-risk will always run the same sequence of pseudo-random numbers every time a simulation is performed. If you change the seed to a choose randomly option, then every time you generate a simulation, you will end up with slightly different results. 57. On collect distribution samples option, leave it on the all option. This setting specifies how at-risk collects random samples from input distribution functions during a simulation. All specifies that samples will be collected for all input distribution functions. In other words, at-risk will store in memory iterative information of input variables. This is the way to eventually create tornado charts. Since a tornado chart is, in essence, a chart that depicts the relationship between inputs and outputs, if this option is otherwise selected at none, then no information will be collected on input variables. Therefore, it would be impossible to draw a tornado chart. Since one important part of the final analysis is to determine the relative importance of each one of the elements in our model, then it is important to leave this option on all. Consider that this means an additional storing process in your simulation, thus creating a slightly slower simulation and a more crowded usage of memory. 58. On smart sensitivity analysis, leave this option enabled. By default, at-risk uses a smart sensitivity analysis on. To do this, it pre-screens inputs based on their precedence in formulas for outputs. Inputs that have no direct or indirect link to an output cell are removed from the sensitivity analysis, thus avoiding spurious results. Smart sensitivity analysis is performed because it is possible for simulation data to show a correlation between an input and an output when, in reality, the input has no effect on the output in the model. Without smart sensitivity analysis, tornado graph bars could be displayed for those unrelated inputs. Since we want to analyze the relative importance of each input variable on determining total annual profit, we need to leave the smart sensitivity analysis feature on. 59. On the update statistics functions, leave it at its default of at the end of each simulation. This option specifies when at-risk statistic functions, such as risk mean, risk target, etc., will be updated during a simulation. In most cases, statistics do not need to be updated until the end of a simulation, when you wish to view final simulation statistics in Excel. 60. Exit the simulation settings dialog with OK, as we will skip all the sections on the next 2 tabs of macros and convergence.